Rise and shine, porcupines. You know what time it is. It's Algebra with Al time, and I'm your host, Al Rosetti. So we're covering Chapter 2, Unit 2, identifying different types of functions. So when you're done here today, you should be able to identify the different functions. The concept is identifying functions, and the skill is being able to transform them into slope-intercept. Okay, so what do you think? What do you say we get started? Here we go. So let's take a look at what we got here. Okay, so they want us to identify whether or not these are linear functions. Well, linear functions have to be written in the form of y equals mx plus b. So if we can write those in that form, we don't even have to graph them. We know it's linear because it's in slope-intercept form. All right, so take a look at number 1. So we got y equals 3x. Okay, slope-intercept. The slope is 3, the y-intercept is 0. So yes, it has to be linear. All right, let's take a look at number 2. Well, all they've done is taken slope-intercept and they just mixed up the numbers, but it's still y equals 5x plus 2. Yes, linear, because we're able to write it in slope-intercept form. Number 3, okay? So 2x plus y equals 10. Once again, all they did is move a few things around. You can tell this is linear, but let's put it in the correct form by subtracting 2x to the other side. We get y equals negative 2x plus 10. Slope is negative 2. The y-intercept is 10. So yes, linear, because we're able to transform it into slope-intercept. That's the key. No table of values, no graphing. All right, number 4. We have 4x squared, okay? Linear? Well, as soon as you see that squared term up there, it is not linear. Do you know what that squared term, what function that represents? If we graph that, it'd be a parabola. That would be a quadratic. Anytime you see a squared term, you know it's a quadratic. So based on this problem, not a linear function. All right, here we go. Keep going. All right, so let's take a look at this. So can we write this in slope-intercept form? Well, you have 2 over x, right, plus y equals 15. Well, for this to be slope-intercept form, what are you going to do? You can't have the x as a denominator for slope-intercept. If I subtracted, or if I just rearranged it and subtracted negative 2 over x, that's not linear, okay? It has to be in the slope-intercept form. Okay, look at number 6. What do we have? All right, so we have x minus y, right, plus 8. Now, all we have to do to put this in slope-intercept form is subtract 8 from both sides, and you have what? Y equals x minus 8. Slope is 1, y-intercept is negative 8. Obviously, yes, it's linear. All right, look at it, number 7. So you have g of x, right? Now, remember, g of x and f of x, any alphabet letter and x is the same as writing y. So don't let that mess with you. G of x is y equals 8. There's no slope. The slope here is 0, but the y-intercept is 8. Yes, this is linear. It's a straight line right through 8 on the y-axis. All right. Last one here, number 8. We got h of x, like we said. Once again, that's just y, so that's okay. But then we have the square root of x plus 3. Not linear, okay? Cannot be under a square root. So basically, if you see anything, if you're asked if something is linear and you're not sure, if you see anything oddball, like the square root, you see x as a denominator, anything to a negative power, you got a 99% chance that it is not linear, okay? All right, so here we go. It says write each equation in standard form. Identify a, b, and c. Now remember, standard form of a linear equation is ax plus by equals c. Now obviously the a, b, and c, we're going to replace those with values. But basically the x and y are on the same side. It doesn't really matter the side, but x and y together equals some value. All right, so let's take a look at it. So number 9, we have y equals x, right? So what are we going to do? All right, so all we have to do is subtract y from both sides, and you have x minus y equals 0. That is a linear function, and in this case, a is 1, b is -1, and c is 0. All right, so y equals 5x plus 1. To put that in standard form, all we have to do is subtract the 5x over, but standard form, the x cannot be negative. So we'd have one last step here, and that would be to divide everything by -1. The y can be negative, but not the x. So we have 5x minus y equals -1, a is 5, b is -1, and c is -1. All right, 11. What do we have to do here? All we have to do is add 7y over to the left, and we have 2x plus 7y equals 4, a is 2, b is 7, and c is 4. Yes, linear. So we want x and y on the same side. That's what we need to do to transform it into standard form. All right, we're on number 12. So take a look at that. We have 3x minus 2y minus 2. Now what do we have to do to put this in standard form? All we have to do here is add 2y. So we have 3x plus 2y equals -2. Standard form. ax plus by equals c. All right. A is 3, b is 2, and c is -2. As long as you have it in that form. You know that old Michael Jackson song, A, B, C, right? As long as you have it in that form, it's always going to be just like that. The first term A, the second term B, and after the equal sign is going to be your constant C. All right. 13. Here's 14. Now we got -6y plus 14 equals 8x. What are we going to have to do here to put this in standard form? Well, all we have to do is add the 6y over, and we get 8x plus 6y equals 14. Now, I know that many of you are used to having your x and y on the left side, but that's like middle school math. It's okay to have the x and y on the right side and a constant on the left side. Nothing changes. So don't let that worry you. If you feel the need to switch it, go ahead, but really, we're all grown up now, right? All right, let's take a look at what we got here. All right, it says it wants to find the x and y intercepts, okay, and then graph them. All right, so finding the x and y intercepts is built off of putting it in standard form. Once you have it in standard form, we're going to substitute one of the variables with 0, set it equal, the other one equal to the value, and then it's a one step to solve it. So let's take a look at it. So we've transformed the first one into slope-intercept, right? We have 3x minus y equals 6. We make y 0. What do we have? We have 3x equals -6, right? So x is -2. So that's the x-intercept. There's no slope, there's no counting. When we put it in standard form and eliminate one of the variables, we have the intercept. All right, let's try the y-intercept now. So you're going to do the same thing. You're going to take 3 times 0, right? And then minus y equals 6. So what are you going to get? You're going to get y equals -6. There's your intercepts. There's the graph of what it looks like. All right, moving on to 16. We have y equals -2x. Okay, standard form first. We got to add 2x to both sides. So 2x plus y equals 0. Now, the math is to substitute in 0 for y, but essentially just take 2x equals 0 and y equals 0. If you want to substitute in the 0, you can go through all the steps, go ahead. But 2x equals 0 and y equals 0, and you'll have your intercepts. Okay, so there's your, both x and y are 0. Now look at the slope. The slope originally is -2, right? -2/1. So to graph it from 0, 0, we're just going to go down 2 and over 1. And there you have your graph. It is linear, obviously. All right, 17. X plus y equals 5. It's already in standard form, so what? X is 5 and y is 5. Now I plugged in the zeros, but do you really need to do it at this point? You understand the concept. Just set them equal to the answer and go from there. So we have x is 5 and y is 5. There's the coordinates on the intercepts, and we draw a line. And once again, linear, obviously. All right, so now that we have that, let's look at number 18. So we have 2x plus 5y, right? It's already in standard form. Do we have to put y, 0 in for y? Can we just go 2x equals 10 and 5y equals 10 and understand why we're doing it? We don't need to do that now, right? So here we have x is 5 and y is 2. We're going to put our first coordinate on the x-axis at positive 5, our second coordinate on the y-axis at positive 2, and we draw a line. So you don't need to have everything in slope-intercept form. You can keep it in standard form, do some simple math, and you can use the intercepts to graph. You don't need to have everything in slope-intercept, okay? But if you're comfortable with that, then do it that way. But just understand there is another way, and I think easier than transforming to slope-intercept. Okay, so we have that. And that's all we have time for today, boys and girls. Thanks for being here. Remember, math, math, math. Get off your ass and do some math. I forgot that. Get up and do some math. I forgot.
It's all right.